Hello guys, my name is Devin. My YouTube channel is DRG Bros. Today we're going to be talking about trigonometric integrals. I'll just spell that out for you. Trigonometric, because it's just I was using a new pen. Trigonometric integrals. Good easy. So, yeah, we're basically just going to use trigonometry in integrals. So, trigonometry basically is just with the sine and the cosine. And this is just a rule. Just going into this, just so you know. The cosine squared of theta plus the sine squared of theta is equal to 1. Cosine squared of theta equals 1 minus the sine squared of theta, and the sine squared of theta is equal to 1 minus the cosine squared of theta. And also, so if we draw a unit circle here, like a triangle like this, if this is 1 and the angle here is theta, this is the cosine of theta, and that's the sine of theta. Just gonna use it. I'm gonna have two problems for you, and they're both gonna have the variables m and n, okay? So the first one is if m and n are not equal. The second is if they are equal. I don't know why I just circled that. That doesn't really make much sense. So, the first problem we're going to use, I'm just going to get out another page. The first problem that we are going to do, please, just thank you, paper, is going to be the integral of minus pi in pi, the cosine of mx, cosine of nx dx. Sorry, my pen's just not working. I think I got it working. Okay, so that's going to be equal to the integral of minus pi to pi. Forewarning now, these problems are a little long. Both of them are about a page and a half. So, just saying. And we are going to use a bit of a varied u substitution. Okay? So make sure to check out my other video on that. So it's going to be 1/2 of the cosine of mx plus nx plus the cosine of mx minus nx and parentheses bracket dx. That should be like that. Next, we're going to integrate the integral, or is it differentiate? I don't know, I always get mixed up. So it's going to be 1/2 bracket the integral of minus pi and pi, the cosine of, I think it's, double parentheses, m plus n x dx, like that. Plus the integral of minus pi and pi, cosine of x, it's going to be the cosine of x, no, it's going to be the cosine of double parentheses mx minus, I'm just messing this up. It's going to be the cosine, just ignore everything I've done so far. It's going to be the cosine of double parentheses m minus n x dx is the end. Alright, I'm sorry, my pen's not working. I'm going to swap pens. There we go. So next it's going to be equal to, where am I? Oh yeah, no, here's where we do the u substitution. So we're going to substitute both sides, but we're not going to do the v's. We're just going to do u. So u on this side is going to be parentheses m plus nx, and du is going to be equal to m plus n dx. And the other side, it's going to be almost the same thing, except it's negative. So u equals, and I know I said no v, we're kind of like splitting the problem in half, like right there. So on this side, u is going to be equal to m minus nx, and du is m minus n dx, like so. So it's going to be equal to 1/2 bracket the integral of minus pi and pi. You always say the bottom number first if you didn't know that. The bottom number of variables. So this is minus pi and pi, the integral of minus pi and pi, instead of the integral of pi and minus pi. If it were like that, the variables would be swapped. Just a little inside. So cosine of u du over m plus n plus the integral of minus pi and pi cosine of u du over m plus n. Or m minus n, sorry. My notes are like really unclear. So that's going to be equal to 1/2 brackets 1 over parentheses m plus n, and the integral of minus pi minus pi and pi cosine of u du plus 1 over m plus n, the integral of minus pi and pi cosine of u du over m minus n. Sorry about that pause there, I didn't see the minus. They're confused. Okay. So we're almost done with this problem. So it's going to be 1/2 bracket 1 over m plus n bracket sine of u, and I forgot what this thing is called, but it's basically the thing where you like integrate the numbers on the integral. If I remember what it was called, I would tell you guys, but I don't, unfortunately. Plus 1 over m minus n sine of u, the integration thingy, and then you're going to do 3 brackets here because of this bracket, no, this bracket. Why are there 3 brackets there? Am I missing something? Oh no, there's only 2 brackets, my bad. It's only 2. I don't know. My notes are very bad. 1/2 1 over m plus n. So now this is going to be the sine of pi minus the sine of pi, and bracket, plus 1 over m minus n sine of pi minus the sine of minus pi. Both of these are minus pi's. My bad. Alright, I need another page. So now it's going to be equal to 1/2 1 over m plus n, 0 because the sine of pi radians, which is what we're doing with trigonometry, is 0. Let me show you. So, I think how it works is we have our unit circle, and pi is on one side, and like 2 pi is on the other, and 2 pi is full 360, and pi is only a 180, and the sine of 180 is 0, if that makes sense. But yeah, it's 0 minus 0 plus 1 over m minus n is 0 minus 0, okay? Now, this would, because if you multiply anything by 0, it's 0, 0, under one condition. M and n cannot be equal. Do you know why? It's because of this right here. Not just that, but just the m minus n. If they were equal, they would be 0. And this is undefined. Or any number up here. N divided by 0, where n is any number, is always undefined. However, 0 over n, where n is any number, is just 0. Let me try to explain why. So in division, basically, we take something into a set number of groups. So in the division problem, 6 divided by 3 equals 2. Basically what that means is we have 6 objects, 1, 2, 3, 4, 5, 6, into 3 groups, which means that there are 2 per group. And I'm pretty sure all of you know that. Now, in this case, down here, let's just say n is 1, just for simplicity. Let's just say n's 1, okay? We have no objects and 1 group. So how many objects go in that group? 0. Because there is nothing. Now, in the other case, we have 1 object and nowhere to put it. It's undefined. Because there is nowhere to put this one thing. Now, what would happen if m and n are the same? That's the other example I was telling you about. So I'm just going to do it on this page, actually. So it's going to be, let me just mark 2. So it's going to be the integral of minus pi and pi, cosine of mx, cosine of nx, dx. So that's going to be equal to the integral of minus pi and pi, the cosine. Now, if m and n are the same, m can turn into n and n can turn into m. So we're both just going to turn them into n right now. X cosine of n x dx. Which is going to yield us with the integral of minus pi and pi, the cosine squared nx dx. Make sense? Okay, now we're going to move on. Yeah. I'm messing up so bad right now. I'm choking so hard. Okay, so that's going to be equal to the integral. I'm just going to say the integral right now because it is proper to say the whole thing out, but it's pretty much the same through the whole problem, so I'm just going to say the integral. Just going to put that out there. So then it looks like we factor out the square root, so that's going to be 1 plus the cosine of 2 dx over 2. Now, this one's actually longer, so just warning you. That's going to be the integral of, just the integral, 1/2 plus the cosine 2nx dx over 2. The dx doesn't get divided by 2. So now we're going to factor in the integral. So it's going to be the integral of minus pi and pi, 1/2 dx plus the integral of minus pi and pi, cosine of 2n x dx divided by 2. What next? Now we do a u substitution. So u is 2nx and du is 2n dx. So now it's 1/2 of x, the integration thingy. That is a very bad pi. Let's just say that's a pi. Plus 1/2 brackets of the integral of minus pi and pi, cosine squared nx over 2 dx. Sorry. Is that not the wrong thing? Cosine of u du divided by 2n. That's what it is. I'm actually choking right now. Sorry, guys. 1/2 bracket of pi minus pi, close bracket, plus 1/2 the sine of u over 2n, and then the integration thingy. Alright. So now it's going to be 1/2. We're going to add the minuses, or however you want to say it. So it's pi plus pi, end bracket, plus 1 over 4n, because we're factoring in this 2n. 1 over 4n, parentheses, or bracket, sorry, the sine of 2nx. And then the integration thing, so pi and minus pi. Then it's going to be equal to 1/2 of 2 pi, still in the brackets, plus 1 over 4n, brackets, sine of 2n pi, minus the sine of 2n pi, in bracket. So then the 1/2 and the 2 are going to cancel out, so it's going to be pi plus 1 over 4n, 2 sine of 2n pi. Okay. End bracket. Don't forget to end bracket. Okay, next page. It's going to be pi plus 1 over 2n, because we're going to get rid of the 2 there, and we're going to divide it in, bracket, sine of 2n pi. Alright, we're almost done. Last 2 steps. So then it's going to be pi plus 1 over 2n, the sine of 2 pi n. Now we already know that the sine of 2 pi is 0, right? And we have 2n and 2n. So we can actually rewrite these as 2, is it 2 pi n? Yeah, 2 pi n. That's actually what I had written. Pretend I didn't write that. So, boom, 0, 0, and that's just 1. So the answer is just pi. That's just the answer. So that's what happens if m and n are both equal. So thank you very much, guys. I hope you enjoyed. Sorry, I'm trying. the topics I'm making videos on are getting harder and harder now, so I'm trying to keep up as well. But yeah, thank you for watching. Please subscribe. Yeah, bye guys.